Hey everyone! For billions of years, Earth has been a sitting duck in a cosmic shooting gallery. But guess what? We're finally shooting back. Let's dive in.
You know, for pretty much the entire history of our planet, we've basically been a target in a cosmic shooting gallery. But for the very first time, humanity is learning how to shoot back. So today, let's break down Earth's brand new survival guide. Think about it. For almost its entire life, our planet has been completely defenseless. I mean, just ask the dinosaurs, right? But very, very recently, something fundamental has shifted. We, as a species, have decided to stop just crossing our fingers and hoping for the best. And that's really the key here, isn't it? The solar system, it's not this calm, empty place. No way. It's more like a chaotic, active construction zone, and we are living right in the middle of it. So this threat? It's not some what-if scenario. It's constant. So how exactly did we go from this vague dinosaur-level fear to having a modern, active strategy? Well, it all started with some very real and very recent wake-up calls. Okay, so these two events really put the modern threat into perspective. First, you've got the Tunguska event back in 1908. A rock, maybe 50 meters across, just flattened a huge chunk of Siberia. We're talking an area the size of a major city. Then, fast forward to 2013, and you get the Chelyabinsk meteor. This thing was less than half that size, but its shockwave injured over 1,600 people. It's a huge reminder that you don't need a planet killer to cause absolute chaos. And just to put that Chelyabinsk event in perspective, we're talking about a rock that was only about the size of a house. But when it exploded in the air, it did so with a force of 500 kilotons. Let that sink in. That is 30 times more powerful than the atomic bomb dropped on Hiroshima. And the craziest part, it never even touched the ground. But here's the kicker, the really scary part. With all our fancy telescopes and tracking systems, we were completely blind to it. We never saw it coming. Why? Because it approached from the direction of the sun, hiding perfectly in the glare. And that right there revealed a massive, terrifying blind spot in our planetary defense. So, learning from stuff like Chelyabinsk, scientists now keep what is basically a cosmic most wanted list. They're actively tracking and categorizing anything that gets a little too close for comfort. Let's meet some of the top suspects. So scientists kind of break these down into different weight classes. You've got the huge planet killers. The good news there is we found about 95% of them, and thankfully, none are on a collision course. Phew. The real worry is the city killers. They're big enough to do immense damage, but they're small enough to be super hard to spot. And then you've got the sneaky ones in stealth mode, the ones that use the sun's glare as camouflage, just like Chelyabinsk did. All right, meet suspect number 1, Bennu. Now, Bennu is weird. It's not a solid chunk of rock. It's what scientists call a rubble pile. Seriously, just imagine a flying mountain of gravel, barely held together by its own weak gravity. This makes it an incredibly tricky target. If you try to push it, it might just act like a giant cosmic beanbag and absorb the hit. Or even worse, it could shatter into a shotgun blast of smaller rocks, all still heading our way. Okay, next on the list is this monster called 1950 DA. This thing is over a mile wide and it's spinning so incredibly fast that by all rights, it should just tear itself apart. But it doesn't. It's held together by these tiny forces we're still trying to understand. But here's the good news. We have a ton of time. Its potential impact date isn't until the year 2880. So yeah, we've got a few centuries to figure that one out. And it's really important to remember that this science is changing all the time. Not every threat ends up being a real one. You might have even seen headlines about an asteroid called 2023 DW. For a little bit, it was on the risk list, but as astronomers gathered more data, they were able to confirm it's going to miss us completely. It's a great sign that the system of detection and refinement is actually working. Okay, so we know the threat is real, and we're identifying the suspects. This is where the whole story pivots. We are no longer just passive observers. Because for the very first time in history, humanity has a playbook. This right here, this was the absolute game changer. In September of 2022, NASA's DART mission proved that we can physically change an asteroid's path. I mean, we actually did it. We played a game of cosmic billiards from millions of miles away, and it worked. This was the moment planetary defense stopped being science fiction and became cold, hard fact. So what's in this new playbook of ours? Well, it boils down to 3 main strategies. First is the Kinetic Slap. That's exactly what the DART mission did. You just ram the asteroid to nudge it. Simple, effective. The second is the gravity tractor. This one's a bit more elegant. You park a heavy spacecraft nearby and let its own gravity gently tow the asteroid onto a new, safer path. And then, well, there's the last resort, the nuclear option. And no, we're not talking Armageddon style. The idea is to detonate a nuke beside it, using the blast of radiation to push it away. Having a defense plan is fantastic, but it's pretty useless if you don't see the punch coming, right? So now we're building the next generation of asteroid hunters to seriously upgrade our early warning system. And you can really see the momentum building. 2022 was the DART impact. Now, in 2024, the European Space Agency's Hera mission is on its way to go study the results. By 2027, NASA plans to launch a brand new asteroid-hunting telescope. This isn't just one group. This is a coordinated, global effort in action. A great way to think of the Hera mission is as the crime scene investigator. NASA made the impact, right? Now, Hera is on its way to analyze the crash site. It will get there in late 2026, and its job is to measure the crater, analyze the debris, and tell us exactly how effective our kinetic slap really was. This data is absolutely vital for planning future missions. And that brings us to the NEO Surveyor. NEO just stands for Near Earth Object, and this space telescope is our best shot at finding them. Remember that blind spot from the sun's glare? Surveyor is specifically designed to fix that problem by hunting for the heat signature of asteroids in the infrared. Its primary mission is to find 90% of those dangerous city-killer asteroids that are currently undiscovered, giving us our best set of eyes on the sky yet. So, when you put it all together, the tracking, the confirmed defense methods, the new missions coming online, it really marks a profound shift in our relationship with the cosmos. We've gone from being a target to being a defender. And this is maybe the most important takeaway of all. We can't stop a hurricane, we can't stop an earthquake or a volcano, but an asteroid impact? That is the one major natural disaster that we have the knowledge and the technology to see coming and to prevent entirely. The solar system is still a dangerous place, no doubt about it, but we are no longer just waiting for the next impact. We have the maps, we have the math, and we have the means to defend our planet. For the first time in its long, long history, Earth is shooting back.
That's the shot. Now it's your turn. Comment Planet if you think we're ready for the next asteroid. Like and sub to stay in the loop.